In our last section, I'm going to speak about recombinase polymerase amplification, which admittedly is a mouthful, but RPA from here on out. So going back to the slide that Philip showed earlier, where Watchmaker is really focused on a variety of things that are necessary for the point of care and field-based assay developers. What we're going to focus now more is on the isothermal side of it, which goes into the ease of use, the idea about being able to do this out in a non-laboratory setting, ideally no instrumentation whatsoever in this case, which is something that is achievable with RPA as a method. And you know, there have been a few talks today where we talked about isothermal. You've seen LAMP a lot more. That is the one that's much more well known. But there are some distinct advantages of RPA. First and foremost is primer design. It's just two primers that are generally very PCR-like, except for a couple of nucleotides longer generally, whereas LAMP 4 to 6 primers per target, and there are these kind of strange hairpin loop things that are a challenge, to say the least. But probably even more importantly is the amplification time. RPA is faster, generally about half the amount of time, and it has a much lower incubation temp. Optimal is 37 to 42 versus in the 60s for LAMP, but we have had a number of our RPA partners who have actually been able to design RPA reactions that can run at ambient temperature. So they're literally doing this out in the field, no instrumentation whatsoever, and they're just combining that with a lateral flow, type detection strip. So just literally nothing but plastics and something can be run just right wherever you are. And they have similar levels of limited detection, well within any relevant range that we'd be interested in for these type of things. But really with RPA, it's is there a bunch of something there or not? It tends to be a yes or no answer. But when we think about RPA and take a little bit more detailed view of it, there are some advantages and there are some historical challenges with using this methodology. The advantages of it, it's really great for lyophilization. It's really great for the field-based type assays that I talked about because of the temperature and some of the things that you can do. It's also quite tunable. You can tune for speed versus sensitivity, but in order to do that, you need to have individual enzymes that you can do your mixes with. It's great for inhibitor resistance, and it is multiplex capable as well, and I'll show you a little bit of information on that. Historically, there have been some challenges, like I said, however, one of which is that it is a little bit more complex as far as your enzyme mix. So where I will give credit to LAMP, it is a single enzyme, RPA does require 4 different key enzymes to it: UVSX, UVSY, GP32, and the BSU DNA polymerase. And one of the challenges with RPA that people really struggled with for quite a while is, for a long time, there was just a kit that you could buy that was just, everything was pre-mixed, and you just had kind of one choice. You couldn't optimize that in any way. So if it didn't work right out of the box for you, there wasn't a whole lot you could do with it. So that gave rise to companies starting to develop and start to individually supply the RPA enzymes, which was great, but there were some challenges that came along with that as well, one of which was freeze-thaw stability. A lot of the ones that you can buy still today, you thaw them, you got to use them, or they're dead. There's no refreezing them. And the other big one that we've heard from a lot of our partners is lot-to-lot consistency. You would buy, a lot of UVSX or something, and you use it, and you need to optimize your reaction, and the next time you buy it, the activity is completely different. And so there's just no way to get a good reproducible assay, which is not, something that's really makes RPA, historically didn't make RPA good for the types of things that we're talking about. But that said, we have at Watchmaker have spent an enormous amount of time figuring out the best way to make these enzymes stable and reproducible. So we have made them freeze-thaw stable. This is actually data from 30 freeze-thaws, and we're not losing any activity for our enzymes whatsoever. And then, and this is all designed to be glycerol-free for lyophilization compatibility, everything that goes along with it. We've also spent a lot of time thinking about the activity of the enzymes. If you buy most RPA enzymes right now, you're going to get a certificate of analysis that says, yep, it gives you an RPA amplicon, and that's all it's going to tell you. So what we did is design the first ever assays, QC assays, where we can actually individually measure the activity levels of those individual enzymes, which allows us to tightly control the enzyme and the activity that you're getting, so that when you get that next lot or the third lot or the fourth lot, you can be confident that you're getting exactly the same activity levels, which will allow you to develop your assay and have a really reproducible one that you can use time after time after time. So once we got past that, then we really need to help people understand that RPA really is a viable method for POC and for field-based type assays. So I'm going to spend the majority of the rest of my talk talking about just giving you some information about speed and sensitivity, show you some inhibitor tolerance, multiplexing, show you some RT-RPA data as well, and then cycle back just a little bit at the end to talk about some of that activity and also your choice of DNA polymerase that you would want to actually use in RPA and why. So let's talk about speed of RPA. This is one where we've optimized for speed, and we've done just, there are a variety of different ways you can actually read out RPA. This is literally just an Agilent tape station, but we see lots of gels and things like that. This is a fluorescent-based kind of cyber-like version to look at it. Most people are using it with a lateral flow output as their final, but this is a little easier to visualize as far as this goes. And we're doing anywhere from 1 million down to 100 copies here. And what you can see on the time axis below, we're getting up to maximum fluorescence for basically an endpoint in well under 10 minutes across the board here, across a very wide range of the types of inputs that you're getting to, well down to the sensitivity that most people would be interested in. But if you really do want to push down the sensitivity, you can do that. And so here we use Pseudomonas as a target, and this line is approximately 15 copies of that. And we optimized this one for a little bit better on the sensitivity side, so we did run it a little longer, but you can absolutely get down into those, sub 20 copies, type of thing that you're interested in, and really that's as far as anybody would want to go for these types of assays anyway. Inhibitor tolerant wise, if you really think about where RPA gets used, so we're talking about, in point of care or field-based applications where you either don't want to do extraction or purification strictly from a time perspective, so turnaround time and cost, but also in a lot of cases you're literally not in a setting where extraction or purification is even possible. So if you want to do something like that and you want to have a lyophilized assay that you can just input a sample to and wet down your sample and get your results really fast, I highlight like saliva here and UTM, universal transport media. So you could imagine a situation where you're taking a nasal pharyngeal swab, you're putting that in your UTM, and then that UTM can just go directly into that reaction. Or somebody spitting in a tube, same thing. You can pipette some of that saliva directly into that assay to be used for RPA, and you can get successful amplification using this method quite easily. All that's great, and many times it's a single analyte you're looking at, but in most cases, molecular diagnostics assay developers are looking for, multiple analytes that are related. So be it an RSV, flu, those type of things, and multiplexing absolutely is, within the realm of RPA. And here I'm demonstrating both a triplex and a quadruplex, and I'll just focus on the triplex for now. So this is Pseudomonas, and then we've added a couple of other targets in here. These are individual amplifications. You can see nice strong bands, and then this is the multiplexed version of that, where all three of those targets are amplified at the same time. And then we've done it with 4 different targets over here in the range anywhere from 156 base pairs up to 430, so well within the typical amplicon size range that anybody's interested in when they're doing these types of assays. And along with that, we all know that a lot of the time viral targets, and RNA targets are the most important things here. So here we just did a duplex in this particular case, but this is, 2 amplicons starting with RNA, in this case just MS2 for ease of use here. And we literally, the only thing that we did differently was add in our stellar script HT plus that Philip was just talking about to this reaction to reverse transcribe your RNA and cDNA, which then just goes right through. And this is all done at a single isothermal amplification temp. You don't even have to change that between the two of them. So it works beautifully as far as that goes, as far as a method. And then I want to come back to and talk about activity for a minute. So if you remember, I told you that we were the first ones to really develop individual activity assays for some of these RPA enzymes. And I'm going to focus on UVSX as one of the critical components of RPA overall, which is actually, one of the ones that's most important. It's also one of the hardest ones to actually manufacture and do right. And with our assay, we're able to look at the activity of each of these enzymes. And I want to point out, this is the watchmaker UVSX, and this is another commercially available UVSX. And you can see about 3 times the difference in overall activity. And these are loaded the same amount of mass of these enzymes. And UVSX always gets sold in, milligrams or nanograms, those type of things. And so you can use both of those, absolutely. But when you have an enzyme with lower activity, this results in lower yield and or slower speed, so slower turnaround time. If you want to overcome that, you have to use more enzyme, which of course adds more cost to when you're trying to develop your assay. So you don't want to have to add more cost, just for something to overcome a version of an enzyme that just has lower activity overall. The other thing that we've seen in a number of cases is the thought process of using BSU versus BST as a DNA polymerase. BST is well known in LAMP, and what you really need to remember is what the optimal activity temperatures are of these assays. So RPA has a really nice activity level, in that 37 to 42, but as I've mentioned, we know that RPA developers are actually doing ambient room temperature amplification. And you can see even at 37, the activity of BST is extremely low compared to BSU. And at room temperature, it's going to be virtually non-existent. So if you want to drive down your reaction temperatures and get into those ambient level type things, you're going to have to use BSU and not BST for something like that. And so with that, I want to wrap up on the RPA side. And just to remind you that RPA is indeed a really great method that is, highly amenable to lyophilization, to those field-based or point-of-care type assays, absolutely capable of multiplexing and, viral targets for RT-RPA. We at Watchmaker have developed these individually QC'd, individually available enzymes for assay developers to be able to optimize and get the best possible performance out of whatever target that they are trying to actually detect. These enzymes will be officially launched in December, but they are available now in early access. So if anybody's interested in getting on their hands on that, tomorrow, come talk to me. And you can see me at our poster, ID 42, on Friday morning. And then lastly, just to summarize, and then I will take questions if anybody has any, just as a reminder, Watchmaker, our core skills are around protein engineering and manufacturing capabilities that are going to give you the highest performance, reproducibility, and stability of your enzymes. On the qPCR, RT-qPCR side, as Philip went through, we've got a great new suite of inhibitor-tolerant solutions for you. On the RPA side, we're going to give you the most consistent, highly active enzymes that are possible. Everything that we're doing is designed to be lyophilization compatible right off the bat. That's what you're going to get. There is no secret menu. You don't have to say, hey, what about those? Is that somewhere that I can get? And then lastly, I want to finish up by saying that we do have a dedicated custom genomics solution team that their sole purpose is to work with our partners for OEM relationships and to help with our assay developers' needs to make sure that they get everything that they need. And we will be your partner throughout as you're developing your assays with our reagents.